Good morning, class. Welcome to the online classes for physics of class 11. In today's session, we are going to start a new chapter, that is one energy and the power, that is the sixth chapter. So here we are going to know about what is work, energy and the power and how they differ from each other. So firstly, we will be saying what is work. We know that this work you have read in class 9th also. In 10th, I think you have read this chapter in 10th, that what is work and what is energy and the power. So what is work? Work is said to be done whenever a force is applied on any body, right? When the force is applied on the body, we say that we are doing some work, right? Or the work is done by us. But if the body is not displaced, can we say that the work is done? No. Because if we want to do some work, then we have to displace that object. If you are trying to push or pull, because this is a kind of force, so if you are trying to push or pull an object, then there will be some displacement in that object, because we know that whenever we apply the force, the body starts moving or there is a change in the position in the direction of the body. So whenever this body is changing its position, that means it is displacing. So whenever a body starts displacing, we can say that we are applying the force on it. And on applying this force and the body is displacing, then this together displacement of the object due to the force is said to be the work done. But think of an example that if you are standing at your room and you are trying to just push your wall, and you are trying it for 2 to 3 hours and you are wasting your energy also. And you know that you wasted your energy and you will feel also that you have stressed out now. But whether anyone will come and say that you have done a lots of work today? No. Why? Because you are doing that work which the object is not displacing there. You are just trying to move that object and you are trying to apply the force on it so that the body can change its position. But whether the body is changing its position? No. The body is not moving at all. So we can say that if displacement is 0, that is displacement is not there in this wall. So if displacement is 0, then the work is also 0. So work is only will be said that the work is done when the body is to be displaced from one position to the other. If the body is displaced, then only the work is said to be done. So work is said to be done only whenever the force is applied on the body and movement is there in the body due to this force, and that too in the direction other than the force. So we can say that the force acting on the body is the first condition that the body will start moving. And we know that if the force is applied on the body, then the body will start moving, but in the direction of the force. And if this body displaces in the different direction to that of the force, then only the displacement is done. And we know that if we apply a force and if we try to pull or a push, simple example, if you try to pull something towards you, then the object will displace in the direction of the force, that is the object will displace towards you. And if you want to push an object, that is you are applying the force in the direction of the push, then the object will go away from you, that is you are applying the force in the away direction, so the object will also move in the away direction. So the body is displacing in the direction of the force itself, right? So what we can define the force as, that is force can be work can be defined as the amount of the force applied on the object, and due to these applied force, if the object is allowed to move, or the motion of the object due to this force and the moving object in the direction of the force is said to be work done. So work done can be defined as the force applied on the object with the displacement. So if it is moving with some direction, then the magnitude and the direction is together there, so we will be taking as displacement because it is a vector quantity. Distance will not be taken because direction is also there because it is moving in the direction of the force. So here we can say that the component of the force, we are applying its magnitude and the displacement of the body with the direction of the force, and the product of these together we can say it as a work done. So work done can be defined as force into displacement. It is a formula for the work done. But if we are trying to move that object by applying the force with some angle, by taking in some angle or inclining with some angle, we are applying the body with a force that is with some angle theta, then the body will be displacing. Now this can be given as that you can see here in the figure that if force is applied. Now what is the example for this kind of force? Like if you are tying a thread to some playing toy and you try to pull it towards you or you try to drag with you, then what it happens that if you try to drag it, it will easily drag with you, right? By pushing it or pulling it will be some more work done will be there. But if you're trying to drag it with some angle and by trying it a thread on it or trying any string on the body, then we can just displace it very easily, or the work done can be reduced. So we can say that if the body is placed with some angle and the force is given with theta, then we can say that the horizontal and the vertical components, if we dissolve this force into its component, that is work done, will be given as with some angle. That is, force will be resolved into F cos theta and F sin theta. So work done also be taken at the angle itself. We know that force is equals to force into displacement is given by the work done. So work done is equals to force into displacement. But we have seen that if we move an object or we try to displace an object with an angle, or we are applying a force with an angle theta with the surface, then some horizontal angle is to be applied. That is, if object is moving in horizontal. However, we are tying the thread and we are trying to move it with an angle, but the object is moving in horizontal direction. So we can say that if his body is moving in the horizontal direction, then the force applied on the body will be equal to that with the angle of the horizontal component. So the work done will be depend only on the horizontal component of the force, that is F cos theta, and the product of this force and displacement is given by the work done. So F cos theta into S, that is displacement, is given as a work done. So work done can be defined as force into displacement or as Fs cos theta. So we can say that cos theta is for the dot product. So work done can be defined as the dot product of the force and the displacement. So we have seen that work can be defined as that whenever force is applied on the object and the object is displaced by some distance or the position change, then it is said to be work is done. So this is what there is some elevator or any element that if we want to move it, so we are displacing that object from one position to the other. Now we say that force is applied, that's why it is moving out. So by moving that, we can say that the person is just doing his work by displacing that object. So we can say that if the object is displaced, then only the work is done. If displacement is 0, then work done can also be 0. Okay. So what was the work done's formula? That is force into displacement, that is change in the position, can be given as del x or del d or del s. So every books are in different refreshers, different terms will be used. So don't be confused that it may be change in the position can be given as del x, change in the distance can be given as del d, or the displacement can be given as s. So it is F dot d, that is displacement and the force. It is dot product of the force and the displacement. So the angle given by the force and the displacing or the horizontal component is given as cos theta. So force is equals to Ft cos theta or Fs cos theta. So what is the unit for the work done? We know that the force is given by Newton and the angle is given by degree or radian and the displacement is given by meter. So together the work's unit is given by joule. The other unit is also there, that is erg. Okay. And we have seen that by applying the force in the angle or with an angle, we know that the body will move with the direction of the force itself. But if sometimes it happens that if you apply the force in your direction and the body displaces in the other direction, then the work is said to be negative because it is moving in the opposite direction to that of the direction of the force. And similarly, if we are applying the force and the body is moving in the direction with that of the force, then it is said to be the positive work. So here you can see the example that the positive and the negative work, that the person is applying some force and is trying to pull it in its direction, but the object is displacing in the different direction. Similarly, in the positive work, he is trying to pull it in towards himself and the body is also displacing towards himself. So we can that the displacement and the direction of the force are similar or in the same direction, so we can say that it is a positive work. Okay. So this is what the positive work is. So see here that the quadrants are also given here. Positive work is in the first quadrant. This is what the first quadrant is. That is 0 to 90 degree. It is the first quadrant. So whenever the force is applied in the angle within the first quadrant, that is 0 to 90 degree, then the work done is said to be positive. That is, positive work is done. If the theta varies from 0 to 90 degree or 0 or 90 degree, because cos 0 is 1, and if it come to 90 degree, then cos 90 is 0. If work done is 0, that is angle is 0. Okay, so work done will be 0. So from 0 to 90 degree, if angle is there, then the value of the cos theta will be positive. So work done will also have the positive magnitude. Similarly, for the negative, see it that it is moving from 90 to 180. So whether it is 270, 100, 120 or any angle, then if it is between 90, 120 and if it is taken in 270 also, then also it is a negative. So from 90 degree to 270 angle, that is 90 degree to 270 degree, then the work is said to be negative. So work is negative work. Similarly, if we take the angle with 0 to 270 or 270 to 90, then it is taken as a positive work. So this is what the positive work done and the negative work done. So what we can say, that whenever a body moves in the direction of the displacement or moves or displays in the direction of the force, then the body is said to be moving in the direction of the force, and it will be a work done as positive. So value of the cos theta will be positive. So the work done is also said to be positive. For example, when a body feels under the gravity, we know that whenever the body falls freely with the gravity, under the gravity, we know that no other forces is acting on the body. So gravity is positive because it is falling, and the direction of the gravity is also downward direction. So both are acting in the same direction, so the positive work done will be done. Similarly, when a force pulls a cart, the applied force and displacement are in the same direction. So work done of the horse or by the horse is positive. Similarly, what is the negative direction? If that is negative work. If we say that the direction of the force and the displacement are in the different direction or in the opposite direction, then we say that the work done is negative. So the value of theta will be in the direction with the value of negative. So the negative, it shows as the magnitude, so the work done will be negative. Similarly, example that the body slides against a rough horizontal surface. Here the friction is working. So friction just opposes the direction of the motion. Here the body is moving in the downward direction. So both are opposing each other. So we can say that the body slides over a rough horizontal surface. It displaces its opposite direction to that of the friction. So friction is also a kind of force. So it is moving in the direction opposite to that of force. So the work done can be said as a negative work done. So what is zero work? Now if when the cos theta is 0, that is theta will be 90 degrees. So cos 90 is 0. So we can say that the work done is 0 only if the force applied on the body is with perpendicular direction, or the angle between the force and the horizontal displacement is taken as perpendicular or taken as 90 degree. So the work done is said to be 0. So what are the dimension of the work done? That is force into displacement. That is force is given by mass into acceleration, the kg meter per second square. So it is given mlt minus 2, and distance it is given as L. So together we can write as ml2t minus 2. That is the work done. So this is the dimensional formula for the work done. Okay, and here we have seen that the unit of the work done was joule in the first slide, but now we can see that the SI unit was joule, and for CGS unit we can write it as ergs, and ergs is given as 10 to the power 7 times of that of 1 joule. So 1 joule is equal to 10 to the power 7 times of ergs. Okay, so here what we have seen in this formula, that is force is equals to Fs cos theta. From there, if we just take its rectangular components, or we just resolve into the vectors, that is into with unit vectors, then it can be written as taken as the x-axis, the unit vector will be I. For the y-axis it will be j cap, and for z-axis then it will be k cap. So f, the components of the force will be taken as fxi plus fyj plus fzk, and displacement will be given as sxi plus syj plus szk. So together, on taking this dot product of f and s, it given as force and displacement together, dot product will be the work done. So we have read that the Fs, that is product of force and displacement, is given as work done. If we take the horizontal component of the force as an angle with the theta, that is with the direction of the displacement, then it will be Fs cos theta. And we know that if the body is raised from the height, we know that the gravity is working on it, along with that the displacement is towards the height. Then we will be changing or replacing the word displacement with height. So it will be mgh, and the displacement is height, and the force here will be due to the gravity. So it will be mgh. And if the body is moved inclined at an angle theta with a constant speed, then the work done will be given as mg sin theta. That is the vector quantity. So this is an example that the gardener pushes a lawn roller through a distance of 20 meter. If he applies a force of 20 kg in a direction inclined at 60 degree to the ground, find the work done by him. Take gravity as 9.8 meter per second square. So force is taken as 20 kg per weight. 20 kg weight is given, right? Weight is a force, that is m into g, and m is mass, and g is gravitational acceleration. So g is taken as 9.8